I have a couple of folks here from the mentoring service, and they would like to explain it to you. So, take it away.
Hello, everybody. My name is Adrian Vargas. I am a CS peer mentor. So I'm just going to read off a couple things, make sure I get everything. What we do is help first-time CS students get adjusted to San Jose State University and the CS program. We assist you with time management, study skills, and finding resources on campus. So if you feel like you're confused or lost and you need someone to talk to, regardless whether it's about just your problems or maybe classes, you can come to us and talk to us, and we can help you find the means to fix it. This is Andrew, who's going to tell you how to set up appointments.
Yeah, my name's Andrew Jones. I'm in my fourth semester. I'm a transfer student. And I'm the other peer mentor for the computer science department, so I'll be seeing a whole lot of you. Basically, to make appointments, you go to this website, advising.cs.sjsu.edu, and there's a link for a peer mentor to make appointments. You click on that, and it basically brings up like a Google calendar thing, and you just click on either one of us for a time slot, and basically put in your info, fit a request there, and that's pretty much it. So definitely you want to make use of us as a resource. You know, we can point you in the right direction for a lot of things. We've been in your shoes. You know, if you get overwhelmed or don't know what to do, don't know, you know, who to turn to when you have this gigantic programming assignment and you're just like pulling your hair. Oh my God, I'm like totally stuck. Yeah, we've been through that once or twice. So yeah, definitely don't be afraid to ask us any questions and kind of reach out to us. And yeah, we can definitely help you out with any of that kind of stuff. Yeah.
Does anybody have any questions about setting up appointments? Okay. Well, I mean, I know you haven't probably gone to the actual website, but there's an image just of a calendar. You click on it and you sign into your Google Gmail or Gmail and set up an appointment with either me or him. It's going to show up little tabs or little slots that you can sign into. It's going to tell you which one to sign up for either one of us. We're here to make sure you succeed. We're supposed to know about the resources, anything to help you. So just please come to us if you have trouble with it. I was corporate financial management before I switched over to computer science, and it was really tough for me to get used to just programming. So I know how it is, and I know it's tough. I spent over 10 hours every day in the tutoring center, and trust me, it's tough. So I don't know how tough it is for some of you. Maybe some of you have a lot of experience. And if you don't, come to us. We'll help you.
All right. Well, thank you very much. So definitely take advantage of this. There will be some of you where I will be sending you an email telling you that after looking at your scores, you should definitely make that appointment. And so for those of you, if you get an email from me say go, then you have to go, and I'll find some way of making you regret if you don't. But even if you don't get an email from me, by all means, talk to these folks. I'm glad that we have right now the resources to offer the mentoring and tutoring, and it really has been helping students succeed in this class. So we do want all of you to pass this class, and so that would be great if those of you who need extra help, if you could make that your first step. All right, thanks very much.
Thank you.
All right, moving on. Oh, other questions? No questions? Homework too easy? I can work on that. Yes?
I was going to ask, I was a little confused on the concept of the movement method with including gradients.
Okay. So that's, let me see which one that is. That's part A?
Yeah.
All right, so get out my sketch pad here. So I have my bug here, and it has a position, that's the X and the Y, and it has a direction. So let's say it points this particular way, then that's given by the dx and the dy. So when it moves, then it puts itself to here. And when it moves again, then it again moves by dx and dy. It's going to be here. If it moves again, actually, did I say by moving by a particular, a move 0.5. So this is if you call move 1. So right now I said move by 1. Now let's say we move by 3. Then it moves 3 times as much. So this would be a move by 3 units. So moving by 1 is simple. You just add dx and dy. And the way it's rigged is that the length of that vector is always 1. To move by 3, you would have to move by 3 dx and by 3 dy. So you would add 3 dx to x, add 3 dy to y, and that's your new position. And so in general, of course, to move by some value, whatever, s, it would be s times dx and s times dy. So you just multiply the dx and dy by whatever you want to move, and that gets you the new position. Now to turn, the dx and the dy change. So let me blow that up a little bit because that picture is getting kind of crowded. So, the green is a little unfortunate, huh? It's blue. So if originally dx and dy are like this, and now I say I want to rotate by 30 degrees clockwise, then let me, yeah, I can't do that. Then afterwards, dx and dy have changed, right? Now the old dy was this, and the new dy is different. And that to know how to compute the one that requires a little bit of trigonometry, so I've given you the equations for that, and those are the equations that you find here. So the effect of these equations is to come up with new values for dx dy, where you still have a vector of length 1, but it now points somewhere different. And so you kind of have to take those on faith or go back to your trig to find out where they come from. Does that answer the question?
Sort of. But when you're saying it's moving, is it moving from, let's say the grid is dotted at position 0, 0,
Yeah.
0, y 0, and then it moves forward 3, let's say,
Yeah.
like upwards to the first arrow you drew,
Yeah.
and then you ask it to move again,
Yeah.
but you tell it to turn down, right? And you say move forward down 3. Is it moving from the end of the first arrow? Or
No, it's going to be moving from its current position. Let's actually play through a little scenario here to make that more explicit. So let's say that right now we are at 0, 0. And then I call bug dot move, say 1. What is my original direction? It faces east, right? So after that, the bug is now at, I'll make this a little large, at 1, 0. And now let's say I'll turn by 45 degrees, turn. Then it's still at 1, 0 because it didn't change, but now its direction has changed. And actually, when you follow the math, you'll see that both dx and dy are square root of 2 over 2, or approximately 0.7. I'm sorry? Well, I see. So your question is, how do you do that? And we're again running ahead a little bit of the textbook here. To compute a sine or a cosine in BlueJ, you have to use math.sine of dx. So it's not just sin, but it's math.sine. Yeah, sin by itself does not work. Yeah, good point. No, I would put that inside the turn method. So let's actually. But can I finish this one and then I mean, that's a very good question. So I'll come to that in a minute. So right now the bug is still at 1, 0, but its dx dy have changed to point this way. And now let's move by, say, 3 units. Well, that would now move us in this direction. And now when I compute, then it's going to say dx is, the new dx is 1. That's the old dx plus 3 times 0.7. So that's approximately 2.1. Probably a little bit more because I've rounded off pretty brutally. And then dy is 0 plus 3 times 0.7. So that's, actually this is around 3.1, right? And this is around 2.1. So that would get me to, oh, I must have made a mistake somewhere because this one moves downwards, right? So I think dy is negative, so it would be minus 2.1. And so then I get to be maybe here. Yeah?
That issue is also in the tester. I noticed if you give it a positive 90 degrees, it rotates clockwise and starts to...
Well, the rotation is supposed to be clockwise.
Oh, okay.
That was the definition of it. And so the equation that I gave you, I had to double check as well which way it goes because I can never remember which way is clockwise and which way is counterclockwise. But I remember trying that out. So the rotation is meant to be clockwise. Yes. So over here where it says 90 degrees clockwise, and when you look at, oh, I see. I never really specified that. Yeah. Oh yes, you will get that. You will get like 6.7 times 10 to the minus 16 or some such thing. That's fine. And the expected value is 0, and that's just life with finite precision. I mean, I can't very well say I expected it to be, a specific tiny number. I don't know which tiny number comes out of it. And NetBRAD is actually smart enough not to put the line in red when it finds that the number is very close. So, and in fact, I was kind of happy that that showed up not to be exactly 0 because these round-off errors are a fact of life. And so you should simply recognize that 0 and 10 to the minus 16 are the same thing and not worry about it. All right, so let me go and into BlueJ and set this up real quick here. Okay, so we've got a tester. Now, I'm not sure you were supposed to see this one, but I guess now it's there. So the state was private double y private dx and now we were wondering about the move method. So it gets an angle. And we have these nifty equations here. Where are they? So now I pasted those in. Those compute the new positions, so eventually I'm going to have to say dx is new dx. dy equals new dy. Oh, just as an aside, I'm doing it in these two steps. Do I have to do it in two steps? Or could I simply say over here dx equals, and over here dy equals? Yeah. Yes, that's exactly right. So if I over here, if I were to already assigned a dx, then since I'm still using the dx over here, then I would be using the new value, and the math would no longer work. So in this case, at least for dx, you have to do it in two steps. For dy, admittedly, you don't have to do it in two steps, but it seems easier to understand it this way. Now, this will almost work, except, of course, I actually have to write the multiplication as multiplication. Huh? Yes. Thank you. No, I'm not there yet. I'm not there yet. It's a little. I guess I'm clearly not a touch typist. All right, here. And then the cosine and sine, you have to write math dot in front. That's just the way you do it in Java. So we do that. No, the negative sign is fine. We need a minus sign here. And then finally, there's an issue that the angle here that's denoted by alpha has to be done in radian. And to convert from degrees to radian, there's a method called math to radian, I believe. So to radians. What? Okay. Let's do control space. Yeah, here we go. Control 2 radians. All right. And compile. All right, and that worked. Notice, by the way, that I can use alpha as a variable name. So even though it's, it looks like it's a Greek letter, you can use letters from any alphabets, from any Unicode alphabets as a variable name. That's not what I expect most of you to do. Most of you will probably write ALPHA or some such thing. That's just fine. I just wanted to show that you can do it. You have a question?
I noticed you had UDX and UDY as local variables. Is there any harm in having those?
Excellent question. So he said, what if I make these into instance variables? Yeah, new, yeah. And not into. So, and then over here you wouldn't say double, you would just assign to them. And will it work? It'll work. Is it good? No, it's not considered good. And the reason is that now you've increased the storage requirement for every bug by, as it turns out, 16 bytes. And so the bug now carries those extra 16 bytes with it all the time, when it in fact only needs them in the churn method. So it just turns out to be more efficient to allocate the variables for the shortest lifespan possible. And even if you don't care about efficiency, it makes the code easier to read when a variable has the shortest possible lifetime. Because right now, when I look at this code here, I'm going to have to worry about what if other methods also use these ones here, and do those interfere with each in some way? So it makes it harder for me to keep the code correct. So the rule of thumb is that if you use a variable only in one method, and then you don't need it again, don't make it into an instance variable. Leave it as a local variable. A variable that's used in more than one method should be a local variable. So over here, x and y are needed both by turn and by move and by getx, getY, of course. So those should really be instance variables. They belong to the long-term memory of the bug. But these newx, newdx, newdy were very tactical variables, so those should not. So let's move those back to local. Okay, other questions? All right. No other questions?
Oh, I just noticed something for the tester for part C, the final.
All right.
When you input the code, it's not a big deal, but NetBrat attempts to test each line one at a time, or it expects one line at a time.
Yes.
But, if you have a slash in your text that you input, the program prints that out in 2 lines, but NetBrat's only expecting 1.
Yes. You have to be careful with those things. I hope I didn't make a bug there. I thought I specified exactly where I want those blank lines. And if you don't put those blank lines just so, then NetBrat is going to get out of sync with what you're producing, and you simply must go and put another blank line in there. So be very certain how to do that. Someone said, this probably is answered by now, but someone asked on Piazza, how do I put a blank line? And you use the /n. So you put a /n somewhere in the string, and that produces the blank line. Make sure that those blank lines exactly match what NetBrat does. It only takes you an extra few seconds to do it. Yeah, just try it. You'll see. It's immediately obvious what happens. You put it into the string wherever you want the blank line. So, like, for example, if you wanted to have a blank line after the colon, you would put colon and then a /n. And that produces one blank line. You probably want 2 blank lines, so it might be colon, /n. It depends on how you exactly set up your set of strings. But it's quite possible that you just need to put 2 of them. And you can just fuss with it until it works. Well, if you put print, I don't think you are putting print or print on, right?
You're not.
But you're just generating the string. And so that's taken away, that decision has been taken away from you. The string needs to have the right number of new lines. Oh yeah, in general you have that extra control, whether you use print or print on. But the space has to be inside the quotes. Yeah, sure. Yes?
Okay, on the quick 7, question 6, it asks, hello world, which one fits on someone?
Okay, let me look. Where do I find this? No, quizzes. Quizzes. Quiz 7. Oh, I see. Oh, that's yes, that's a little different from what we were talking about. because this is a question of what happens in a graphical program as opposed to what happens on the screen with system out print on. But still, it's a great question. Oh, I made this one, yes. Of course it is. So, and this is one where you need to take out your graph paper, which I happen to have some. And let's see. So we have the first string, hello, at 5100. So this is x is 50, y is 100. Then we have world also at 5100. Well, that's not going to work, right? Then because it's going to print hello. And now this is in graphics, it's going to print world right over it. On the console window, you could never achieve that effect because every character on the console window is by itself. But in graphics, you can draw anything, so you can write it on top of it. Now, here there is a new line in the string. And I don't actually know what would happen if you did this.
I don't think that's the right answer.
Someone else said to a similar question, why don't we just try this out? So let me in fact do just that. See if my book code here somewhere. Oh, I don't. Give me a minute here. No, there is book. Project. Pokemon BlueJay. Book. Chapter 3. So I'll pick a program that's kind of similar. Didn't I have an alien? Oh, that was in chapter 2. The face. Here we go. Okay, that's the one I want. And now in the face component, there's a call to draw string. So let's see. First of all, let's see what happens when we run it. And then down here it says hello world. Now let's see what happens when I put a new line in here. It didn't make a difference. So that can't be the right answer. And now this is one of those things where there really is no great, wonderful way to figure this out other than to try it. What's that? Apparently the implementors didn't think it was worth worrying about. They just didn't think this was, they just chose to treat all white space as space. Just the way it is. Yeah, seems unfair, but hey, life is. And so, if I put a few more of these here, just to make sure it really. They just put them all in a row. In fact, they don't even, if you look carefully, there's not even a blank space between them. They completely ignore it. That's what they did. And they've done it for years, so they're not going to change. So that knocks out answer number 2. Now let's look at answer number 3. Back to my graph paper here. It's nice to have graph paper with undo, actually. So we have x, y at 50, 100, and now we have the second one. X is 50, and y is 150. So x is still 50. And y is 150. So x goes in this direction, y goes in this direction. And now we put world here. Oh. Well, that seems to be a winner. Now they are on top of each other. And then one can just have a quick look at here and this one here, 100, 100, oh, that's over here. 50, 100 is here, 100, 100 would be over here. And if you put it here, then they would be horizontally aligned and not vertically. There was this other question with these touching ellipse, and someone said, well, how the heck am I supposed to know? What I intended people to do is get out their graph paper and sketch some of those, and those are, of course, more tedious to sketch. So now we look at the 140, 140, 40, 40. So in a situation like this, it does actually kind of pay to be really careful about it. And so we'll put our origin here, and now I'm just going to go 14 boxes over. So I'm going to say each box is 10 wide. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4. So that would be here. And so now it's 40 by 40. So I'm going to draw the bounding box. And then the ellipse, of course, sits inside. So it would be sitting inside somewhat like this. Let's hope that that's this one here. Now, the original one was 100, 140, 40. Well, now that I see how the math went, the bounding box for that would be this one. And the ellipse would be this one. So they clearly don't touch. And then you kind of have to do it until you find some that do touch. 110, 110, 20, 20. That the bounding box is then this thing here. Well, the ellipse is going to be inside, so they have no chance of touching. The third one was 100, 110, 20, 20. Okay, x goes this way, so the 100 is this way. So that the bounding box is this one here. And they will touch. Right, they will touch right here. So that's what I did when answering that question, because I suspected that one to have had a bug in it, and I really did go to this point, and then I sketched the fourth one. It didn't touch either. Now, someone put a brilliant suggestion out on Piazza and said, just run it. Just copy and paste this into some code and see what happens. And so that really is a so much better suggestion. So let's do this. And so again, you take a program that's kind of similar. So I'm just going to take here the face viewer again. That way I don't have to worry about the structure of the program, and it all basically works, and I can just experiment inside it. So here's my ellipse. Then I'm going to take all of this other face stuff here away, which I don't care about. So no, I don't want the head. But I want to draw this one here. And I also needed to worry about the original one. That is this one here. How long do they give you to take the test? You have any amount of time that you like, right? So there's no... So as long as you give yourself a little bit of time for these kind of experiments, then it's okay. I understand you can't stop it. Once you stop it, you lose. Okay, oh, there's a double equal here. That's a typo. And now here you see, well, they clearly didn't touch, so that wasn't it. And then you can try it with the others. Let's do the one that did work. That's this one here. Oops, wrong one. Let's go sit down here. And here you see the touch. Now, was that cheating? Yeah, totally. But so what? I mean, you, by doing that, now you've gotten a little bit better with running BlueJ really quickly, and that's a really useful skill too. Because, like in an exam situation, some such question might come up, right? There might be something where you say, gosh, which way did it go? You don't have the time to look it up, or you just don't know where to look it up. And if you can run a very quick experiment like that, I mean, that can give you valuable insight, and so there's nothing wrong with that. Yes?
While you're at it, can you run the fourth answer?
I'm sorry?
While you're at it, can you run the fourth answer?
Could I do what?
Can you run the fourth answer?
Oh, sure. I'll leave it on here. All right, here. Yeah, now you could say, no, do they touch? Right, and now, oops, I wish the other one went away, unfortunately. Now, it's the rule that you always have with multiple choice. Now you're going to have to figure out, which is the better of those two answers. And yeah, right, it touches in two places, right. And so in this case, I would say they intersect, but they probably don't touch. Did anyone ask that question? There was a discussion about that on Piazza, right? That was you. And did you get a satisfactory answer out of it? Oh, that was.
You said it was a tangent.
Yeah. Yeah. But I mean, I do agree that that might have happened after you've submitted that other answer. It's just 1 point out of 1,000, so I wouldn't get excited about it. But I mean, I think if you see both, then you'd have to agree that the other one seems a better fit for touching. And that's always true, as I'm sure you know from years of experience with multiple choice questions. Sometimes you just have to make a judgment call there. All right. Other questions? Yes?
Yeah, for the move method in the book too,
Yeah.
are we gonna have to use the new dx/dy?
You don't have to, as it turns out, because the equation for new dy doesn't depend on x. So you can simply update x and y. In fact, I don't think the move method changes from the previous. My guess is it doesn't, because it's the same concept, right? Previously we had a distance vector that was in one of 4 positions, but it was still given as dx dy. So my hunch is move doesn't change. Yeah? We're going to talk about that today. Let me actually see what today's lecture is. Shows you how I prepare. Yes. So hold that question. Okay, any other questions? All right, then I can go into this material on drawing. So these sections here are there so that you can write programs that paint some simple pictures. And the rationale for it is to make you write programs that give you a visual idea of what's going on, particularly later when we do loops. It's often very interesting to draw a picture that has a repeating pattern somehow, and it reinforces the concept of the loop, and it reinforces the strategies for designing loops and for debugging them. So the pictures that we're going to be drawing are not going to be incredibly exciting, as you've already seen, but it really is a useful skill to that reinforces the basics. This idea of reinforcing the math and the visual just works really nicely. So Java has a graphics library that lets you do all sorts of stuff, and we're going to do the simplest possible thing. So there's a bit of mumbo jumbo that you have to do to make a frame, and so that you produce this. Don't even look at it. All you want to know is that there is some code that does this, and you want to copy and paste it when you need it. And so in the thing that I had over here, where is it? Yeah. That was this viewer class. So when you open it, it contains a bunch of mumbo jumbo. Over here, you see the title says an alien face. So if later on you want to change it to 2 circles, it seems pretty obvious that you could do that without having to understand what the mumbo jumbo does. So it's a little bit unfortunate that you have to do this copy and paste thing. There is a way of not making you do it. In every edition I try this, and the reviewers say, oh, no, this is not standard Java. And so apparently other people who use this book prefer that one just sticks with the standard Java. And eventually you'll understand what all of these instructions mean, but right now, just copy and paste them. And if you read it, it's pretty obvious when it says set size here, that in all likelihood that sets the size of the window, and if you monkey with these parameters, you can make the window bigger or smaller. So if I wanted to have this window like really large, and I don't even know what it is. I know what it is, but I don't want you to think about it. So now it's large, right? And so that's the degree to which I want you to understand this particular code. So JFrame is, the technical term is, it's some doohickey that we just copy and paste it from somewhere. We just want to understand set size and set title. Don't worry about what set default close operation is. But you can intuitively understand how you modify these settings if you need to. Now, it's also a little bit unfortunate that you need to, in order to show anything interesting at all, you need 2 of those mumbo-jumbo classes. One of them is the viewer class, and the other one is a component class. The component draws the stuff that's inside. So in this example here, the component is the thing on which the rectangles appear. Why can't you draw directly on the frame? There's no wonderful reason. It's just the way that they set up the library didn't make that possible. I could have made a better library, but when I do, the reviewers complain that it's not standard Java. So every time that you want to do any drawing at all, you have to make that extra class, that component class. And I find that incredibly tedious myself. I just had to do a couple of them for the solutions for the next homework, and I always copy and paste them. So if I had to make another component class, let's say I needed to make a new project where I want to draw whatever. Then I would make a new class, whatever viewer, and a new class, whatever component. Then I would take an existing one, like here's a face viewer. Here's the face component. And now I would change all the face to whatever. There's one here. So I can do this with a global replace. All. And let me change these back to what they were. And now I have enough scaffolding that I can go and do something. Oh, yeah, that does sometimes happens, unfortunately. Okay, replace. Next. Whatever. Next. can I replace it?
I think that's in the comments there, it's highlighted, and try hitting next again.
Yeah, that's why Emacs. All right. So now I have them. Will it compile? Yes. All right. So now I'm ready to go to town and to start actually some drawing. So the next thing that the slides then point out is, so here's this basic structure here. You then have to do some other mumbo jumbo with a class called Graphics 2D, and I really don't want to explain that because that's just a design flaw in the library. They just messed up and recovered from it later. And so this part here is just total boilerplate that every one of those graphics programs is going to have. It's kind of like public static void main on steroids. You're not worrying about what public static void main means either. You just copy it every time, and it's the same thing. So you just have to make yourself this basic framework any time that you have to do anything with drawing at all. So actually, as a tip, when it comes to the exam, there will be one such program. You might as well already make yourself a project that contains that basic thing, so that you don't have to type that up in those valuable minutes. So now, what do I want to draw? Let's say, give me a challenge. A sun. Oh dear. Okay. So in that case, I would go and go to my graph paper. And sketch up a sun. So I would have a circle, and then I would have, some number of lines. Like this. And now the tedious part is you have to kind of read off the numbers now. So let's say this is 0, 10, 20, 30, 40, 50. And you'd have to do the same thing in here, so I guess it would be the same thing. So this corner here would be the point 50, 50. Then we say, okay, this thing is, looks like it's 10 boxes long. So this thing here would be an ellipse that starts at 50, 50, and that is 100 long and 100 wide. So let's try that. And even the call to make an ellipse is, as you've seen already in the quiz, is pretty ugly. So it would be kind of nice if we could just copy and paste it from somewhere where we have one, like here. Because you have this nonsense with the ellipse 2D dot double. And it's just unfortunate that it has this very long name. You just want to have an ellipse. And it sure would have been nice if that class had been called ellipse. But someone out there called it ellipse 2D dot double. And we can only hope that that individual will have to pay dearly for that at some point. And that's just the way it is. So, what did I say? 50, 50. Yeah, exactly. So, and then we draw it. So it's all the drawing ones, you use this G2 and .draw, and you should think of G2.draw as the moral equivalent of system.out.println. So in a graphics program, there is no system.out.println. There's always G2.draw. And so G2, is exactly the same thing as system.out. It comes from somewhere, and it just works. Yes?
Would it be illegal to put G3?
I'm sorry?
Would it be illegal to put G3? Name it as G3?
Oh, you can name it anything you want. But if you follow my advice to copy and paste all of the boilerplate, then you wouldn't do that. So I would always call it G2 just because it's there, and why muck with it? So we could draw the ellipse. So when we run this, then here is our sun. Now we see the window is maybe a little small, so maybe I should adjust this thing here and make it 250 wide. All right, now how about one of these rays here? So let's do the one on the top. They're X looks like it's 100, just eyeballing, because there was 50 here, 150 here, and it's in the middle. And so Y goes from 0, say, to 40, so that it doesn't actually bump into the sun. So now I need to find out how to make a line. That's a line 2D dot double. Ray 1 equals new line 2D dot double. And it goes from, what was it? X was 100, 0 to 140. And I have to draw it. Oh yeah, thank you. Thank you. And here's one of them. Now, if we do this one here, this would be 160. Gosh, I'm kind of winging it. Maybe 60. And then it goes maybe all the way up to 220. All right. Oh, not bad. So, and you now do it another 6 times, and then you have your entire rendering of the sun. So the first thing to do is to make yourself that scaffold by taking some existing piece of program and ripping out what makes it the face or whatever it is that you started with. And number 2 is to get out your graph paper and to make a sketch and then just count the squares and figure out what those numbers should be. Sometimes one needs to do a bit of math to figure out the numbers, but for a simple thing like this, you should just be able to read them off. You know, what if you want to have the inside of the sun in bright yellow? Seems like something one might want to do. So in that case, instead of calling draw, you would call fill. And, oops, wrong spot. And you'd have to change the color. So it's set color, set paint.
I think it's set color, but I think you also have to import the color class.
Okay, let's do that in a minute. So color.yellow. I'm sure he's right about the importing. But since I copied it from some existing thing where that import is already present, I didn't have to do that. And that actually seems to be a winning strategy here. If you have an import too many, it's no big deal. It doesn't really cost anything. And once you get to a more sophisticated IDE, it's simple to clean up the import. So I'm never going to tell you that I'm never going to penalize you for putting an extra import. So it looks like the face is the one that you should just use as the starting point for everything, because the face has already so much of the stuff imported, and you don't have to do it. So let's see what happens. Okay, now the ray is also yellow, so if I want those back in black, then I'd have to change the color back to black before drawing them. So over here I might do just that. And now the rays are back in black like they were. Now what if I want to have like a black outline over that thing? Then I want to, after filling, I want to draw it back, and then I have to do it when I'm in black. So then I both fill and draw the ellipse like this. And now you see the black outline around. So it's very typical to develop these things in kind of an incremental fashion. You try something out, you see what it looks, and you improve it a little bit. Yeah? Can I what? Can I put this code into Piazza? No, but you can look at the video. I mean, I copied and pasted it from somewhere else, as you'll see when you replay the video. And you can put it on Piazza. But all of that code exists somewhere. All right, so that's what you do if you want to make a single drawing. So for a single drawing, you need two classes. You need the component class, and you need the viewer class. Now suppose that we travel to a distant planet somewhere where they have two suns in the sky. I'm not sure such a thing exists. Yeah, they have double stars, right? So, yeah, why not? In this case, you might want to draw more than one of them, and then you want to make yourself a class for every one of the things that you might want to draw more than once. In the book, there's an example of a car, and then there's this suburban scene with a couple of cars. And so if we now want to draw several suns, then we want to make a new class, and that class you can just give a normal name of whatever it is that you want to draw. So I want to draw the sun. Now inside there you want to put a method for drawing, and it's common to call that method draw. You don't have to call it draw, but that seems like a pretty good name. And it takes a graphics 2D, because for all the drawing operations you need the graphics 2D, and you'll just assume that it gets passed to you. Now what are the drawing instructions? I'm going to lift them here from the component. They are this. Here's my sun. So there are those instructions here. And then in the component, then I'm going to make just a sun. And say sun1 dot draw, and I give it G2. And so now the sun has become kind of like a gussied up ellipse. It's a thing that can be drawn. So let's try to run this one here. Oh, it can't find graphics 2D, so that I do have to import. Oh, you know what? I'm just going to copy the imports. So now, of course, it still looks the same. Well, what if I want two suns? Then I have to go into my component, which specifies what it's supposed to look at, and I'm going to make another one. So I'm going to draw two. Yeah, it's one on top of the other, right? So if you look very closely, those pixels are a little thicker. So I have to do now something extra. So what I now have to do is I have to realize that these numbers here, let's look at a couple of these numbers. These various numbers here, and the numbers here, let me put those in an extra line so you can see them more clearly. Those here were, if it was in a particular position, and now if I want to move it to a different position, then I have to add something to those numbers. Yes? I'm going to make that in the code right now. And I mean, it would be nice. There's another way of doing it, but it requires a bit more math than I want to throw at it. You could do a transform, but let's not do that. We'll just do it the straightforward way. So the way to do this is to say that every sun should actually have a location, just like the bug did. So that would be an X and a Y. You have to set those in the constructor. And oops, now I'm back in this x equals x trap, so I guess I should call these an x. now that'll work. And then over here, I want to add x and y to all of the x and y coordinates. So it's x plus 50, y plus 50. And do I add them to the third and the fourth one? No, because those are the width and the height, and they're independent of where the thing is located. The line, on the other hand, this is an x-coordinate, this is a y-coordinate, this is an x-coordinate, this is a y-coordinate, and the same thing here. And then for the other 6 lines that I didn't draw. All right, and now when I construct the suns, then I have to give some coordinates. So the first one should be at 0, 0, say, and the second one at 200, 200, or maybe 200, 300, so one sees the difference. And now when I run it, now you see both suns here on the horizon. And now you could, of course, now make as many as you like. And now you might say the picture is maybe not quite large enough, so you go into the viewer class and say, let's make the canvas here a little larger. And now when it pops up, you see them both right away. So this is kind of as complicated as it gets. I have 3 different classes. I have the class for the thing that I want to actually show. I have the class for the component that shows one or more of them. And then I have this viewer class that I just need there because I always need it. Now, if I wanted to now put in like moons and stars, I would then, go and make more classes. And at that point, I would take a similar class. That would be the sun class here. And copy it. So everyone knows that moons don't have funky lines. And say on this particular planet, moons are red. And why shouldn't they? And then in the component, I would now go and make a moon. And draw it. Yeah. What was my mistake here? This is in the moon class. Yeah, the name of the constructor is the same thing as the name of the class. And so when you copy a class, you'd have to rename the constructors as well. A little inconvenient. And now here you have 2 suns and a red moon. Yes, and a partial eclipse. It doesn't get much better than that. All right, so that's how you draw in Java in a nutshell. And so we'll be having plenty of assignments and a couple of exam questions where you're going to have to take your graphic skill and do these things. Now, many people, when they first see this, they say, this is totally ridiculous because I could just go to whatever, a paint program, and do this in 1/100th of a time in a paint program. And that is, of course, totally right, that you could do this here, at least for simple things. When it comes to something where you now have to draw, say, 1,700 moons, then you could still do that in a paint program, but it would be pretty tedious if you had to do like a whole checkerboard of moons or some such thing. So sometimes it actually is useful to do this thing programmatically, but ultimately that's not even the reason we're doing it. We're really doing it because it's good practice in programming. It leads to interesting assignments that make you think about the numbers, think about 2-dimensional locations, think about branches, loops, and that kind of thing. So it's just a good reservoir for interesting programs that probably look a little bit more satisfying than the usual kind of programs that you have in CS1, where you get to print out all the prime numbers up to 1,000 or all digits of pi or something. So while I do realize that you can do this faster with just a paint program, at least it's not as boring as printing the digits of pi. All right, so that's the purpose of this. Let's see where we are with the lecture. So now I've done the entire lecture just with a different example. Yeah, here we have, I didn't draw text in this, but you could easily draw a bit of text into this. So we have colors. And really, the face component one has now proven to be that reservoir of useful method calls. You should just steal from that. Oh, we have clicker questions. Do we have time? Yeah, we have time for a couple of clicker questions. We want to do clicker one. Oh, yes, this is a great question. Okay, let's get this into Piazza. I have a lot of windows. I give up. Okay, so my question is very simple. What does this thing draw? So if you followed along with the lecture on your laptop, this is actually kind of trivial to answer. All right, so what was the right answer? So if you've watched closely, what I was, come on, stay there, here. So if you watched me closely, you will have noticed that the right answer is that there was a compile time error. What was the compile time error? Yeah, that I didn't have any of that G2 and the G2 dot. So let's see how many people got that. Well, 33 people got that. Excellent. So, and I must say, I mean, that's the kind of stuff that is probably much easier to see when you actually do it, right? To look at something like that, and you're also focused on the geometry to see that particular error. I didn't see it either until I tried it out. All right, we have time for. Yeah, let's know. Okay, go ahead and do those things for yourself. They're great little exercises that should help you master this material. So, having done this, that should you won't need it until next week when we have an assignment with that, but then you will definitely need it. All right, I'll see you on Monday.